Well, hello there, YouTube. My name is Tony, and this is TonyLiveTV. And in this video, I'm gonna fix the clock. And I might even fix the tach as well. I'm gonna definitely replace the capacitors in the clock and in the tach. Why not? In the previous video in this instrument cluster series, I replaced the gears, so why not replace the capacitors in the clock and in the tach? I'm also going to check the wiring from the EZL all the way to the cluster for the tachometer, and then I'm going to test for the clock going from the fuse box all the way to the cluster. So you guys ready for this? Let's go! The infamous tach and clock. I'm just brushing it off just so I don't contaminate it any further. My instrument cluster removal video will talk about how I pretty much clean this. So those are the caps right there for the clock, and then there's a resistor right behind it. I've inspected it. Normally if a capacitor is bad, guaranteed to be bad I should say, is that they'll be swollen, they'll be leaking either out of the top or at the bottom. So you just want to look for swelling and leakage. That's the number one thing. But those are those two caps. There's also another cap right behind this 20, and that's for the tach. It's a smaller size cap. That's the gears of this clock. And right now it's set to 4 p.m. or a.m. How would you know? Looking at those gears right now, I don't see anything wrong with the gears, which is a good thing. And that meshes and it's turning. And the clock is turning. You can see the hour hand turns, and so does the minute hand. There's the tops of those caps. Those gears in there look all nice. There's that cap that I was talking about. Well, I think I've shown you everything, so now let's go ahead and test it. What I would do on everything is you want to just make sure, you know, that these things are not loose. Give them a little tug. That's what I would do. Just make sure that they're attached well. Every single one of these, you know, including that ground. I mean, that looks like a good solder joint, and it is. Well, let's test the clock. So what I've done is I've connected the positive to that plug on the back side. So that's connected to positive. I have my power supply at 12 volt. And then all I should have to do is take my negative here and touch it anywhere on this case, and it should, if everything's working, the clock should start functioning. Let's see, I'll connect it right here so you can see that I'm connecting it. All right. The power supply is pulsing, but I don't see that the clock face or anything's actually turning. Do I hear it? I don't hear anything. I don't smell anything. The power supply is pulsing, but it's in perfect timing. So it's a 116, two of those, and I'll need a 4716 for the capacitor that's on the tach. Well, now that I've done that, I think I should actually go to the vehicle and test the wiring for the tach and clock. I have one side connected to fuse 12, because that is the fuse that goes to the clock. And then this is the one that connects to the 12 volt. So let's see if we have continuity. There we go. You know, every single one of these that I see, they're split, right? They always break. I don't know why necessarily, but here's a pro tip. Just take some heat shrink like that and heat shrink it on there, and that will give you a nice tight and watertight connection. So that's a pro tip. Another tip too, you see this? This here has the ground part of it, the other side of this, and it gets corrosion right there. So just use a little emery cloth to make sure those are cleaned up, and then put a little dielectric grease on these things before you reinstall it. That's the only one that I see that has that little ground. And now I'll check the tach. So I have this probe connected to pin 1 of the diagnostic port, X11, And then I have this. This is what plugs into the back of the tach. And so we have nothing on that one, but I've got it there. Ooh, a nice low resistance too. All right, so our tach is getting our RPM signal. That tells us it's getting the signal. Let's check the other side of that plug. There we go. And we don't over there. So we've confirmed that we don't have any short on that side. And we've got our other side of the plug there. So it seems like the wiring in the vehicle is perfect. Nothing wrong with it. Everything is the way it's supposed to be. But as you noticed, I saw something moving, and there it is. It's trying, but it's just going back and forth. Those are those pulses that we're seeing. I can't really tell what's wrong. You know, it could still be the capacitor. And the tach, I don't know. There's no way I can really test the tach. My pulse generator only goes to 3 volts. And I think you need between 10 and 12 volts in order to make this thing go around. Let's start taking it apart. But I'm going to start by pulling straight up. Actually, I got them both at the same time. There's a pretty good close-up of that stem. It's a 2-sleeve stem. It's just like any other clock, and these things just slide on, slide off. So you don't have to worry about the orientation of those needle arms, or whatever the heck they call those things. So I've removed these needles, but what about the tach? If I were to remove this, I'm not saying I'm going to or not. I want to try at least to do it the way you most likely will, because people don't want to remove these. It's scary. You can break it, blah, 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 blah. There's things you got to pay attention to. Of course, there's videos taking out something similar. Mike's Mercedes, he does it. Not this particular gauge, not a tach. I can't remember what it is that he does, but you know, using 2 spoons. It's a proven method that does work, because you can put it on both sides, right, and then pry up. And so you have equal pressure. What I want to do is not remove this, if I can, so I can show that it can be done that way. What I'm going to do is I'm going to remove this. So on the back side of that, right here, there's 2 flathead screws. These 2 right here. Those are the ones you need to remove. It's keyed. These little things are how this thing's keyed in, so you can't mess it up. So go ahead and take it out. Assuming you want to take it out. I do. Well, yeah. So whether or not I can pop it out of there. We need to loosen the screws on the face. You need to do that for the clock anyways, and that's the reason why I'm doing it this way. Nice and tight. And now the critical part. You want to protect this, because if this comes up and you move it or something, that needle may scratch your face. So you want to just make yourself something so you can make sure that you protect that. Now we can see if this is enough to lift this up. It's right on the edge, just like right there. There we go. See those 2 little pins? That's what I was talking about. So it's keyed like that, right? I mean, it's simple. Very, very simple. So I've just kind of taped it on there. So I think that that'll be good. So if I lift this and it hits that needle, hopefully we don't do any scratching. The point is trying to get to this right here, right? We got to pull this up. We also need to clear that. So that's why the plate's got to be loose. But we're going to have to loosen everything in the back so we can get that clearance we need to clear out of this. What I'm going to do now is I'm going to turn this over. That's the reason why I took that long stem off, so I can turn this over this way. Now, before I do anything else, the first thing I want to do is desolder the ground for the clock. And that sits right here. And I'm going to start by adding a little bit of flux to that. And no, I'm not going to just heat that up. I'm actually going to use a wick. There we go. So now that I've got that solder pretty much removed, I think it'll probably just fall right out. The front face is already loose. So now the only thing is just these three. 1, 2, and 3. That's it. Now just hold on to the stem and pull it towards it, so that way there I know that everything is cool. Now I'll go ahead and remove these 2 screws. I'm actually gonna remove this one on this side as well. It looks like you're gonna have to loosen your tach as well, but it's just these 3, not these 2, just these 3. It just has to go up a little bit more, not a lot. See how long they are? So I'll come out on all 3. So now let's see if that's enough room to clear this. Oh yeah, looks like it. We're close. You know what, you guys? Taking out that adjustment for turning the keys really helped, because it made this completely clear. So I can take that out no problem. There's that other cap that I really need to get out of there. So I wanted to show you what I did to get this prepped in order to solder that without removing this. I put these rubber bands on this side so I can see that. That's your capacitor right there. And you see that plus? That's the positive side of that capacitor. So when I put the new capacitor in, we want to make sure that I put it in correctly. Make note of that. I have to desolder that, and I'm not so sure I can do that on camera or not, because it is kind of a tight space. Here's some pictures of how it all looks, so you guys can see how I did it. Nothing's going to fall, nothing's going to get in the way. The needle is not going to get bent, but I feel I have plenty of room to remove this, and that cap basically just falls right out. And there we go. Just kind of wipe it up. Isopropyl alcohol, traces, everything looks great. Let's set this aside. So now everybody knows that you can remove that capacitor without removing that faceplate. And obviously you can remove this as well. And you guys have seen the videos, right? I mean, these are the same for all of these. They're all the same. Every one of them's the same. Just peel that back, right? That's all. Just expose those pins. There it is. See your caps? The plus side. So the plus goes to the outside. So here I am, and this little substance that you see on there is, you know, your flux, right? Just your soldering flux. And that really just helps things to wick away with this wick. Pretty much done. Well, I would say for the most part it's ready, so I'm going to see. There's that side. Just rock it back and forth. Only heat up the leg. Pull straight out. Whoops. That's better. There you go. And there's the other side of the board. Nice and clean. All right, I'm going to test it, right? This thing should read 100. Nothing. Dead. Okay, here's this one. I should note that you discharge these before you test them. Here we go. Doesn't look very good, does it? All right. Now let's check the tach. I should also point out that this is a waste of time because, you know, what is this? My vehicle's in 87, so 38 plus years these capacitors are at least. And you have to take them out of the board in order to test them anyways. You're gonna buy new ones. Let me just say that. Here we go. Not very good. So here's all the information you need to purchase these 3 capacitors, because it matters. The distance between those leads matter. The height, you saw how much height you had and how much clearance you have. This is all the measurements and the diameter, etc. Well, the new caps are in, but I couldn't resist using my other multimeter, which is also that scope. So this is the cap, old cap. It's a 100. Nothing. Nothing at all. Look at that, out of range. And here's the new cap, but we'll hook it up there to the negative and then see what we get. 104.7, 0.8, 0.9, right in there. 105, right? For a 100. That's a good capacitor. Let's check the next one. Short stick is negative. 104.7, 0.5, blah, 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 blah. That's another good cap. And this one here is the old 47. Boy, that's pretty dead. That's the 47, and this is the new 47. There we go. Pretty darn good. So now that I have the capacitors, let me get it all set up and we'll put them in. Before I put those caps in, I just want to mention that you can actually test this resistor that's in here, and you can test it in line with these caps out. Let's test it. There you go, 119.4 actually is what it reads. And that is a 120 ohm resistor. I just want to show you how nice and flat that fits, right, against the board. This is upside down, obviously, but I'm just testing it from above so you guys can see that it just drops right in, and so it fits nice. And after cleaning it up with a little bit of isopropyl alcohol and everything, that's what it looks like. Snipped off the ends. It's not perfect. I don't have as steady as a hand as I used to have. We'll see how the next one goes if I can't get myself braced properly for that one. You're not going to see me solder it. So the cap is in, and as you can see, I have detached this red wire. I'll replace it with wire that I actually have. It looks pretty much identical. Well, that's my repair. It's not perfect. My wire was a little bit bigger, so it was a little hard to get in there. But it's all in. No more bare wire. And the cap is in. It's not bad. It's not perfect, but I bet you it works. Before you put this clock in, I suggest you test it first. My power supply is set to exactly the same setting as before. Here we go. Now, there's something that's really interesting that I want to really show you because this is kind of important. Capacitors can do a lot. One thing it can do is drain your battery. As a matter of fact, right now, if you guys remember early in the video when we tested the clock, it was pulling a current, amperage. That's what that one trigger was. We were seeing it pulsing. Well, what it was doing was charging the capacitor, and the capacitor's bad, and then it's discharging. And it's charging and discharging. Remember I said it's got perfect timing? And it has that draw every time it does it. So then you're wondering, geez, everything works in my vehicle, but my battery drains. Why does it keep draining? I have this low amperage draw, right? Which is what that is, and you don't know what it is. Well, chances are it could be a capacitor in any of these devices that are turned on all the time. And your clock is turned on all the time. So I can see that it's working. Well, I think so. I wasn't watching the minute hand, but you can see the minute hand there. It seems to be moving. Let's do this. Let's set it for 15 minutes and we'll start. And then we'll come back when that thing goes off. So what do you think? Does it look like we went 15 minutes? Well, we're just about there. Ha ha! 15 minutes, and she's still running strong. And I think if we line up our lines right there, that's probably about 15 minutes. I have no idea. We'll see. I'll have to see this in post. But as far as I can tell right now, this clock looks like it's functioning perfectly. And like I said, it's drawing no amperage whatsoever. Nothing. It will last forever. And hopefully we keep perfect time. I mean, we're going to test it here in the future. These are pretty good caps, though. Putting this back together really is the same way. So I'm trying to get that thing through here. You don't have to force anything, I'm sure. There it is. Just try to get this side in. Just about there. Ha ha! Dropped right in. Look at that. I'm going to first secure this face a little bit, just so nothing goes astray. Now I can pull that paper off. Now I just barely tightened it. For now. I'll mention that I cleaned this right here with a little bit of sandpaper or emery cloth. I can see right here that my ground is sticking out. You can see it too. Don't feel right? Back it up. There, see? You don't want to hurt it. There we go. Nice and tight. I want to take care of that tack. You remember that we loosened that all up. We still don't know if the tack works or not. All right, everything's tight. Make sure everything's free. That looks really good. So now I need to loosen those screws so I can put this back on it. It can only go on one way, really. Nothing too tight. It's old plastic. Now the faceplate. So, should we test this thing, huh? Oh, you can see that minute hand turn. Well, that thing worked better than it did. I don't know why, but it sure does. It was easy. It's a lot easier to turn. Of course, I cleaned it all. I think it's ready to be soldered. Everything is tight. My faceplate's tight. All the components are tight. Let's go ahead and put on the needles, the pointers, needles, whatever you want to call it. You start with the little one. And like I said, it really doesn't matter where you put it. You just don't want to put it on too deep. There we go. You see these cuts in that gear, right? That's what we were watching. So I would line up my pointer along that. On the outside edge there's little black tabs. So those little black tabs I want to kind of line up if I can. I'd say it's all on there. Looks really good. Just set it for whatever hour you want and then get your rings where you want them. Oh, that looks pretty good. There you go. Everything's nice and clear. And our needles look really, really good. I have plenty of clearance underneath there. They're nice and level. That's the main thing, right? So when you get around the hour hand, you don't start scraping. This thing's got a bevel to it. This bottom one, the hour hand, it's beveled up, so you can bring this up even closer if you wanted to. But this is how I did it. Before I solder it, I want to just test it. I think, you know, it's the safest thing to do. It's just to go ahead and test it. So, like I said, I've got it hooked up. All I got to do is connect it to this power source, and then I'll set a timer. All right, I've hit the timer. We'll come back. Nope, there it is. What do you think? And it's still ticking away and drawing no amps at all. And you notice that the tach is pointing perfectly, so all that's great. Let's solder that. There we go. After cleanup and everything, that's the best I can do. All right, let's see. I'm getting ready to connect it. There we are. Let's see. Clock is moving. Beautiful. Well, I think that's a wrap for this video. In the next video of this series will be the reassembling of the whole instrument cluster, testing, install, right, and a road test. And we'll see if this tach actually works. So if you're not yet a subscriber, make sure you hit the subscribe button, click the bell, and then you'll be notified when that video is uploaded. If it's already uploaded, it'll probably be listed right here. Thanks again for watching.